Today, I'm going to be talking about FMEAs, specifically PFMEAs. FMEAs help you predict your problems ahead of time. They are super useful, and you see them very commonly in manufacturing. Alright, so what is a PFMEA? A PFMEA is a type of FMEA, and an FMEA is a failure modes effects analysis. They're also known as FEMA sometimes, even though they're not spelled that way. So an FMEA looks at all realistic potential problems that can occur. It then rates these problems with a numeric score. So all your realistic potential problems are your failure modes. And then how bad they can be will be the effects of that. And there's a few criteria you look at. When it comes to FMEAs, there's two main types. Process ones, which is what I'm more familiar with, and design ones, when you're designing a product. There's three main numeric categories for evaluation. Severity, how bad is it going to be? Occurrence, how often does it happen? And detectability, how easily can we catch it or prevent it? Okay, so now we'll dig a little deeper into the actual form and the layout of FMEAs. And it's kind of funny, I've been in a few different manufacturing facilities, and an FMEA is just one of those documents that kind of gets passed around from company to company, at least the general layout. And there's a lot of standards on FMEAs too, how to approach them and how to design them. They're not always strictly followed, but most companies will make an FMEA a very similar way. So the first thing you'll see on an FMEA is the process and function. So what are you doing? Are you pressing something? Are you welding something? Are you screwing a bolt into place? And then, of course, the next important thing is the process failure mode. So what goes wrong in the process? How does it fail? Then next you have the potential effects of the failure. So this isn't the failure, this would be what happens when it goes wrong. So if your failure is the press doesn't complete a full cycle, what's the effect of that? Is the part not completely pressed together? Will that make one of its dimensions out? Does it pose a safety hazard? From here, you can get your severity score. That's your first numeric score you're going to apply to this failure mode. Then we have the potential cause of the failure. So what exactly caused this failure to happen? Everything has a cause. You might need to do a root cause analysis, operator interviews, things like that. A lot of times you'll do an FMEA ahead of time, at least ideally. So you need to talk to people who are experienced with that process. Talk to your mechanical or electrical engineers. So with your potential cause of the failure, how often does this cause happen and create a failure? That's your second numeric score. That's known as the occurrence. Okay, so we have the problem, how bad it is, how often it happens. The final thing we want to look at is current controls. Do we have anything in place to detect the problem or prevent it? This is our final numeric score. Well, I guess our second to last. Detectability. Once you have a severity, an occurrence, and a detectability, those will all multiply together to give you your final number, and that is your RPM, a risk priority number. It tells you how bad the problem is, including all three categories. Alright, so it's important to note with FMEAs, always include a metric on every FMEA you do. And it's good to have a standard numbering approach that the entire company uses. And it's good to have easy to implement numeric values. So for your scales, 1 to 5 works best just because there's less arguing, amongst a score. If you have 1 to 10, people can argue, is this a 7 or is this an 8? But a 1 to 5, there's going to be a lot less arguing. But in general, if you have really good definitions of what a score means, there won't be much arguing. So make your standards as relatable as possible. For example, for occurrence, you could say a score of 3 means the problem happens more than once a year. In my experience, occurrence is the easiest one to define because it's all about frequency. Does this happen once a week, twice a week, 300 times a year, 400 times a year? From there, detectability and severity, it kind of depends on your process. Severity sometimes is really easy to put numbers to, but sometimes it's not. A lot of times you're talking about how angry a customer will be. Same with detectability. You don't always know how often you're catching these problems. As I mentioned before, you're going to multiply your severity, your occurrence, and your detectability, and you're going to end up with something called a risk priority number. The way these RPNs work, the higher the number, the riskier the problem. This kind of gives you a framework for how to address internal problems, because a lot of times these internal problems become external problems. A lot of times customers want to see your FMEAs as evidence of a countermeasure you put into place, as a fix to a problem. But if it hasn't reached the customer yet and you want to address some of these internally, address the higher numbers first. Those pose the greatest risk. It's good to note too, as you put countermeasures into place, reevaluate your scores. If you improve your process or put some sort of mechanical fix into place, and then you reevaluate your process, and your risk priority number doesn't decrease, it wasn't a good fix. You should do something that will make the problem less severe when it happens, or will make it occur less, or will make detectability catch it or prevent it. Those are the best controls. In reality, though, you're not really going to change severity, because if you think about it, the problem that could happen could always happen. So you're not going to put a fix that makes the problem less bad. Not really. But what you can change is the occurrence. You can put something into place that will make the problem happen less often. More often than not, though, you see a lot of detectability fixes. So you put controls into place that allow your operators to catch the problem. Or even better, prevention tools that won't let the problem happen. Just some general useful methods for creating your FMEAs. Recently, I've seen a module system used, an Excel file that had different tabs based on the process, and this was super useful. So if you have a company that does the same type of process for multiple parts or multiple services, you can have a standard template for those individual processes that can be pulled to make multiple parts and services. So if your company does a lot of pressing or welding, just make a general one for pressing. Then every time the customer for a certain part requires an FMEA, you already have a template ready to go for part of how that part is made. So just to clarify on that, say you have a new part and the customer wants an FMEA, and all the part requires to make is pressing, welding, and some light assembly. Chances are if you do that for a lot of other parts, and you have a nice FMEA template that's broken into modules, you can just pull the pieces you need and make that FMEA super quick. You may have to do a little bit of tweaking based on the unique aspects of the part, but otherwise, this is a really smart way to approach FMEAs. So I'll end it on this. FMEAs are a really useful tool for a company to begin looking at their problems and correcting them. It's really interesting to put countermeasures into place and watch your risk priority numbers go down. It means problems will be happening less, and you will catch them quicker and prevent them. It saves a lot of money, and to be honest, it's actually pretty fun to sit around and talk about potential problems. If you have the right sense of humor, it can be very fun.